All right, welcome to Lecture 3, Learning Unit 2. Found some students having some problems with finding our lectures online. I apologize for that. We'll get that figured out pronto. But today's lecture is Introduction to the Built Environment. And we'll kind of give another general overview of building with kind of an emphasis on the energy efficiency aspects of building and what makes a building sustainable from many perspectives. This slide is meant to be kind of a discussion in class, and I guess I'll have one with Brian here, so since he's the only student. Basically, Brian, what do you think is the purpose, needs, and desires of a building?
I suppose at the root level, safety from the elements, also a place of purpose, meaning depending
No, I like that. I like that. A place of purpose, yeah.
Well, you know, it's a place to conduct different types of behavior, whether it's commercial or if it's living. I suppose even storage is a handy purpose for buildings. Yeah.
Okay. I like that. I like that. I like it. Buildings for different purposes. Yeah. I mean, there is a lot of purposes that buildings are for. I come from the residential side mainly, and I think about it as a home mostly, but, building is where we work, building is where we eat, building is where we live. However, this is one of the definitions you can find, a structure with roof and walls. I think that maybe in its most basic form, you can think of it that way. Joe Lestibrick, well-known building scientist from Building Scientists Corporation, one of the founders. I like this quote. He goes, "Basic requirement for buildings is to create an indoor environment different from outdoors. In this regard, buildings are environmental separators. They allow regulation of temperature, air movement, humidity, rain, snow, light, dust, odors, noise, vibrations, insects, and vermin. They must accomplish this in a safe, healthy, and durable manner." So there's just a few things that it must do. I think it's pretty all-encompassing what he says as far as what the needs and desires of a building. Architectural and building techniques have evolved over the last few thousand years into what we consider now as kind of modern building architectural technique that adds a lot of complexity. Now with the industrialization of construction over the last 50 years, we have pre-manufactured homes. We have a lot of new our homes and buildings. We have new materials that are very high-tech, supposed to be assembled in a certain way. New techniques. Modern buildings are tighter, better insulated. Have mechanical systems which actually were not even part of traditional building for many years up until the last 50, 70, 100 years. Didn't really have mechanical systems per se. They just had
a fireplace.
Yeah, a fireplace. That was basically the heating system. So since World War II, there was a big building technical boom, and these new techniques and materials and systems created lots of specialization in the trade. And the complexity and system integration failures that that came from that and that we deal with now really needs a new way to look at it holistically to be able to design a building so that it performs the way it's supposed to, and it's as sustainable and environmentally conscious and efficient as it possibly can be.
So it's an ongoing evolutionary process?
It is, but this is the process that I'm kind of getting to is called the whole building systems approach. And it basically developed by several scientists, building scientists, and physicists, specialists in the building field, architects, engineers, etc. And basically, it's like a holistic approach to integration of all the complicated building systems that go into modern buildings. I use this slide because I like to kind of show this is kind of an idea of a sustainable design. It collects rainwater. It's got, active solar. Has, Energy Star appliances. It's mindful with its water use. It's designed to be safe and efficient. Trees that shade from the east and west, keep it cool naturally. So basically, it was designed in a holistic way to really make sure that everything was kind of working with each other, and the way the systems work in a complicated way can work in a beneficial way, that aren't mutually exclusive, I guess. This approach, the whole building systems approach, is kind of the basis for green building design, our green building certifications. I'll show some of the green building energy certifications here. And the 6 basic categories of green building certifications on the right side here. Pretty much all green building certifications have these 6 different categories where you can acquire points to get your building certified. Site sustainability includes the placement of your building, what improvements you're doing on a specific site, how you're protecting the natural resource that's on the site. If the site has been, you get points for infill, or using a brownfield that's been polluted for your building site, underutilized areas. Materials and resources deals with the sustainability, the durability of the materials, as well as the sustainability, low global warming potential, and low embodied energy, which I'll get to a little bit later in the lecture. Water efficiency, clearly understand the different aspects of water efficiency, but water efficiency is not only something you think about just saving water, but it also saves energy as well, because some of the water we use is heated. Less water we use, less heat we need to apply, and active systems to do that. Energy efficiency, clearly a huge portion of a sustainable building. How airtight and well insulated the envelope is, as well as the mechanical systems, and how efficient they are. Indoor environmental quality, mainly talking about indoor air quality, but then also not only ventilation maybe is what you think of good indoor air quality, but also use of low VOC or no VOC materials, so that the indoor air is not polluted. Indoor environmental quality can also be, proper lighting. We used to like to use natural ways of lighting to do passive lighting strategies to minimize, again, energy as well. And operation and maintenance are an important part of the whole system. That it's operated and maintained well, potentially commissioned at the end to make sure that it's performing properly, and then the occupant is explained that this is how to properly maintain the building, and have a checklist of things that they should know to maintain it properly. That's kind of the basics. Most green buildings. So it's whole building systems approach. Basically, it takes the occupant, the building, and the environment as three main categories of the systems to think about the building as a whole. In between each one of them, there's chemical, physical, and biological reactions that take place. Moisture, heat, and UV radiation also plays an effect on the building, the environment that the building is in, and as well as the occupant. Buildings are tailored for the occupant, but how they interact with their environment, and from a material standpoint, where the materials were sourced from, how far they had to go, whether they're petrochemical material or a more benign renewable resource, lumber, wood, fiber type material. It really plays into the whole building, the sustainability of the whole building. The occupant, he's my son here, lay on the floor with some vinegar bottle. He's doing some recycling actually. But it's the occupant, the areas that we think about when we think about the occupant of the building, and the important things to consider in the overall building is heredity, what their genetic tendencies and traits may be, what operational choices, do they like the temperature to be relatively high, or do they need it to be lower? Humidity, relative humidity is something that basically the comfortable range is between 20 and 60%, I'd say. Maybe ideally 40%-ish is ideal for most folks, but some people have particular needs. They might want higher humidity or
sinus issues.
Yeah, potentially. We have more of an issue with drying here in the West, in our cold, arid climate, and so typically my wife likes to run humidifiers through the wintertime to keep the moisture out in the house. Maintenance, is your occupant going to be on top of the maintenance schedule, or they can completely ignore it and just let everything go? I think most people are kind of somewhere in between.
You say this is the United States you're talking about.
Yeah, well, I don't want to diss Americans in particular, but maintenance, I think probably most occupants are probably poor on maintenance, and being on top of things like, say, the air filter for their furnace, for instance, which almost everybody you look at, if you could just go pull out your air filter, look at it, oh yeah, this thing needs to be changed, it's been forgotten about. We don't have like those reminders on our phone or something that tells us, oh, it's time to go change this stuff. Of course, there's more than just maintaining the filter on your HVAC furnace, but that kind of stuff needs to be done. Operational choices and ease of maintenance is definitely something that we need to think about when we're designing for a particular occupant. Cost, obviously everybody has kind of a limit to or most people have a limit to what they can afford. So typically we try to make it as a balance of form, function, and cost, and thinking about how to make a building appropriately for a certain occupant. Expertise. I'd say probably most building occupants are not necessarily experts in any aspect of building.
Safe bet.
Yeah, I mean, most of us, we just want the building to function the way it should, and not have to maintain, have a high level of understanding of how it should be running to run it. Again, I guess if it's a complicated building that needs a lot of control strategies, then we try to automate those in some way so that it doesn't become overwhelming. Ventilation, accessibility, lighting, those are all other choices that that every occupant's going to have different needs or desires in those different, they might be using the building in different ways. It requires them to need a tremendous amount of lumens to see what they're doing, or they want to save energy, so they don't want their ventilation system running 24/7, or they need it running 24/7 because of their environmental history, which is the next subject. They might have had prior exposure to chemicals and really need a high level of indoor air quality to be able to function properly. Also with environmental history, you see age, I think, and susceptibility. I think a lot of this is kind of like, is this a vulnerable occupant, or is this a fairly healthy, strong occupant? I think when we think about buildings as a whole, we should think about them in regards to somebody who might have an issue with poor indoor air quality or accessibility or prior exposure. Though, if the person was susceptible to some of these, like chemical sensitivity or something like that, then, clearly indoor air quality is going to be at the top of the list of needs in their building. Building itself needs to be looked at from the subsystems, the finishing, and the enclosure and the envelope, and how those all function together. If you take, for instance, if you take a very tight envelope, that could be very efficient, very well insulated tight envelope, and you decide you want to go really efficient and you want to forego a ventilation system, for instance, you can have a lot of issues with that building for the occupant. Besides poor level of indoor air quality, the building could become excessively humid when
it's too tight.
Yeah, I don't want to say too tight, because really high efficiency buildings are very well insulated and very, very tight, but they also include a ventilation system that has high efficiency for heat recovery.
Got to breathe a little.
Well, actually, control.
Condition.
And I'm kind of going outside of the scope of this slide, but yeah, controlled ventilation is important. The new code actually specifies a certain amount of airflow CFM that you need to meet to build a new residential building. It's got to be mechanically ventilated in some way. So how that is done is kind of left up to the mechanical subcontractor in a large sense, because they can either supply, they can either exhaust, or they can do like a balanced ventilation system, which again we'll get into in a future lecture. Anyway, so the subsystems, electrical, HVAC, plumbing, the finishing, appliances, fixture and furnishing, so that they all make up a building. They should work well with each other. They should have been designed and thought about in a holistic way, whereas the building was built tight, and because of that, tight and well insulated. They didn't have to have a very large heating system. But they did need a ventilation system to breathe, for instance. But because it was so efficient, they wanted to use high efficiency fixtures and appliances in low VOC materials because this tight envelope we're going to be breathing in all those VOCs in the building. So that's kind of how you look at the building as a whole and the systems approach. So the environment, you can't forget about the environment that we all live. If a building is toxic to the environment that you place it, it's not a sustainable building. And I use sustainable and sustainability a lot. I kind of think it's the best term to describe a building that is, conscious of, or a building that when it was designed, they did it in a way that they were thinking about all the aspects and the implications of the process and the building itself on the environment. So when we think about the personal environment of the building, I don't really like that, the clothing, diet, and lifestyle. I guess if you're a super active person, you might use a building in a different way than somebody who just wanted to sit there and watch TV and play video games, whatever. You might kind of design it a different way depending on what somebody's personal preferences were. Again, internal, we go to kind of overlapping with some of the occupant categories there. Clearly, a building has to be comfortable and function for the occupant. You can't separate the building from the occupant. From an environmental perspective, I think we also look at so what's the roofing material going to do when the rain runs off? Is it going to run off pollutants into the wastewater stream? Is it or is it going to be a good roofing material that we could actually save the rainwater off of it to drink potentially even, or reuse in some system? Ideally, I think every building would be built as a durable, but also mindful of the environment that produced that material and the durability of the material. You'd hope that wouldn't be entirely at the expense of the environment to make that material durable. But a lot of times when you start to think about it from a cost perspective, you have to sacrifice some things. And typically, people will look for maybe a durable product, but the environmental implications of the manufacturer of that product and over the life of the building, what the product does is not really accounted for. Also, externally, the buildings, the building environment, we need to think about global. We can't just think about, the local site. We all live in this environment together. If we're having extruded polystyrene insulation made in China and we're shipping it here because the pollution standards are different there. Do we feel better about that material, that it wasn't manufactured in the U.S. and that we dump that pollution into the atmosphere in China? Probably not. We all live on this planet together. We got to think about that. Global warming is a reality. A lot of the materials that we use for building impact it, whether it's a greenhouse gas or it uses a lot of energy that creates more greenhouse gases. Embodied energy. I'll get into global warming and body energy a little bit later, but the different aspects of the building, looked at it from the whole building approach, and look at all the implications of the material and the building and the occupant and the environment and the interaction between them, and look at it again in the most sustainable way and comprehensive way. So the design process, typically when people think about a building, and I always fall back to homes. I guess homes are, a building that has a function that most of all of us use. We think about, okay, we have a finite finances, and we need to check to see, basically, we need to figure out what a bank will lend us. Might talk to a financial advisor to get an idea of what will work for us financially as far as payments go, so that we can get a solid number of like what we can afford, and maybe we don't want to take out all the money that we possibly could, because then it's going to stretch us a little bit, potentially. So I guess I think in the design process, first we analyze what really can we afford, and then once we kind of figure that out, we can go to designer. Typically, architect is going to do the actual building design and manage the design of the building with engineers and colleagues on how this building is going to perform, what it's for, etc. And kind of we move from the designer to the builder. Sometimes the designer and the builder can be a team of folks. It's called the design-build approach to building. That's a potential, but most of the time there are two different people. Basically, hopefully they have a good communication between them so that they can accomplish what the occupant wants as far as the design of the building. And then when it comes to actually building your structure, site becomes, site-specific issues become part of the metric. There might be certain adjustments that have to be made by the designer and the builder along the process to accommodate for the specific site. The AHJ, or the authority having jurisdiction, is somebody that is kind of there all along with us, typically in a building in a municipality where you need to get a permit, and there's going to be a building inspector come along and check the different systems once they're installed to make sure that they were done up to code. That's another process. Typally, your plumbing contractor, your electrical contractor, and all the different kind of subs are having their own work checked and whatnot along the process. But the original building permit usually pulled by the builder himself, and that's a process, and it kind of ends with the final inspection and then the certificate of occupancy. So the construction process, once we figure out the design, we're ready to head to the site and start work. We start the excavation, the groundwork, leveling the site. Most buildings are built on a foundation with concrete. They need forming, insulation in the foundation. Some are built on slab. All these take some site work and excavation and rock work and soil, and sometimes soil analysis by a geoengineer and a not, then specific work to that site, that excavation, etc. That allows for the foundation to be placed, the forming to be done, and the concrete to be poured, typically. In that process, there's usually rebar and steel mesh and whatnot that goes into the concrete too to hold it together. Once you get the foundation in place, then we can start the framing process, typically, where the skeleton of the building is erected, and then in most buildings typically sheathed to give it lateral strength and shear strength, and then the roof is built on top and assembled, and we have kind of a shell that hopefully is prepped to be our airtight layer as well at the sheathing side. From there, we do go and we insulate, go through air sealing, detailing, so that it is fairly airtight. Now we do have to meet to current code. We have to meet 4 air changes at 50 pascals, which we will talk about air tightness and blower door testing in the future and what exactly that means. But we do have to build currently to, I'm thinking about residential, we currently have to build to a certain air tightness. Now commercial is also required to build to a certain air tightness. So, methods must be taken to assure that we have good air tightness and thorough insulation throughout the building. Finished work typically is kind of what the occupant wants to look at. You think about, do they want like A, B, or C finishings? A being maybe pretty high end, and C being pretty budget. What's their budget? Typically that's kind of what determines what people, what kind of finish that folks will get in their buildings. Finishing work can also provide a lot of volatile organic chemicals, which I referred to earlier. There's a lot of treatments that are done. New products, just like the new car, smell that you get when you open the door. There's a new home smell that's very similar, if you've ever been into one. And a lot of that comes from the finishing work that's done, because that's kind of the final touches. Finishing work also includes appliances, countertops, lighting, and trim work and doors, door trims, etc. And then furnishings. Are they just going to bring their old stuff, or are they going to buy all new furnishings for their new house? So I like this slide. I was looking for, okay, where's the screw up in the building? And online I found this one and thought that's kind of a mistake. It looks like part of the building fell down actually, and the walls fell over and the trusses collapsed. It's hard to know exactly what happened, but something was overlooked in the process. I guess it's important to realize that there's a process during construction of design and building and finishing that we like to have an idea of the budget and the timeline of it, but quite often we find that during the process we kind of have some issues potentially, or the occupant might change their desire for a finishing, or something they might want to either save money, or they might want a different furnishing or finishing, and they might want to even place the building with a different perspective on the local environment. there's a lot of changes that happen during the process typically, because the process will take 6 months to potentially a year or more to build. A lot happens during that time, and not everybody is on the same page. Sometimes stuff gets overlooked, and typically, I guess from my experience, I've seen that it's the rarity that actually ends up on budget and on time, unfortunately. So getting into some of the more interesting aspects of building implications, global warming potential, and we talked a little bit about this in previous class, but it's a relative measure of how much heat a greenhouse gas traps in the atmosphere compared to carbon dioxide. This is a list here of hydrofluorocarbons that have, for the most part, a much higher global warming potential than carbon dioxide. You see this one, HFC-43, 10 MeE, I think. It's got atmospheric lifetime of 50,000 times carbon dioxide. That would be a bad one to let out. Hopefully your material doesn't contain that. I think probably a lot of these have been discontinued because of their impact on global warming. There's been a lot of focus on building materials and the hydrofluorocarbons that are used in insulations and as coolants or refrigeration systems for like AC units and whatnot, and trying to create them in a way that is more benign and less toxic to the environment and the atmosphere. It's still an ongoing process. I know there's some technologies being developed to use carbon dioxide actually as a coolant in some more sophisticated, high efficiency cooling systems or heat pumps. Are you familiar with that at all, Megan?
Well, I'm sorry, with what?
Carbon dioxide being used for coolant?
Yeah, it was one of the very earliest refrigerants that was ever used, and then it fell out of favor
Because it wasn't.
for decades. And I don't know why exactly initially. I think some of the newer chemicals performed a little bit better, certainly, or maybe a lot better in some cases. But when we revisited, decades later, when we realized we had this global warming or climate change problem, and that refrigerants contribute to that, I think people looked at it and said, well, maybe carbon dioxide doesn't perform as well as R12, but it's not that much worse, and it's a less damaging chemical. So it's coming back into use. Particularly, it's also a lot less expensive as a chemical than a lot of the refrigerants are. Refrigerants that are commonly used in commercial refrigeration and air conditioning systems are very expensive, and almost all systems eventually do develop some leaks, and so you're recharging the system periodically, and there's a cost to that as well as the environmental cost of the fact that it's leaking. Mm-hmm. So now that we have also a shift toward more distributed refrigeration systems rather than centralized refrigeration systems, like in the old style of centralized system, you'd have a rack of compressors in a mechanical room, or in like big industrial systems, a few really big compressors in a mechanical room, and then a lot of piping that would distribute that refrigerant between the evaporators and the condensers. In a system that's coming into favor now, especially in like supermarkets, is one that has many small stations of condensing units and compressors distributed out throughout the building, and more independent loops. Ultimately, I think the total refrigerant volumes can run higher there, so it's better to have a less expensive chemical to fill all that pipe volume.
That's interesting.
So there are different reasons anyway that carbon dioxide is coming back into.
I didn't realize that about the history of carbon dioxide. Is actually, one of the originals, and it kind of fell out of favor maybe because it didn't perform as well. Because in the passive house movement, like their high efficiency heat pumps, they're starting to go back to carbon dioxide. I thought that was kind of a new thing.
It's the new old thing. Like a
The
lot of
new
this,
old thing.
a lot of this sustainable technology, it's the new old thing. You know.
Right.
Finding ways to apply old ideas better.
Oh, it's not just because it's plentiful?
Well, it's partly that. I mean, that's why it costs less, right?
I'm gonna,
But it's less damaging. It is plentiful. It works well enough. Yeah.
I'm gonna stop the recording just to break it up.